Okay, so now let's do some factoring. All right, so I'm going to say this over and over, but in this video, it really won't mean a whole lot, only because in this video, our leading coefficient will always be 1, okay? And um but I'm going to say this over and over and over again. Um the very first step that you want to do whenever you're factoring is take your leading coefficient and multiply it times your last number, okay? And so, and then write that off to the side, okay? So 1, in this case, 1 times 12 is 12, okay? And keep in mind, if this were a minus, I would have to say 1 times negative 12, okay? But it's not, it's a positive. All right, now I want you to think about all of the pairs, and whenever I say pair, I am talking about two pairs of factors of 12. Let's write them all down. 1, 12. Now, and remember, to be a factor, it has to be able to divide into that number evenly, okay? So guess what? -1 and -12. Don't these multiply to be positive 12? Yes, they do. So we can't leave these out, all right? What's another pair of factors? 2 and 6. And then you've also got -2, -6, right? Then we've got 3 and 4, which also leaves us with -3 and -4. Okay, and 5 doesn't go in, and then 6 does, but since we've already got 6 listed over here in this column, we don't need 6 again, okay? And that means that we've come up with all of the pairs of factors that we can possibly come up with. Now what you want to look at is you want to look at the pair of factors and each pair and look at their sum. And what does the word sum mean? S-U-M? It means adding, okay? And so if I look at the sum of 1 and 12, I get 13. If I look at the sum of -1 and -12, I get -13. If I look at the sum of 2 and 6, I get 8, -8, 7, -7, okay? There's only one of these pairs that adds up to be this middle term, okay? Only one of them works. Remember, this one is -7. So I want to use +3 and +4 in my answer, okay? So I've got x, because I've got to put an x there and there. Remember, x times x is x squared, right? Okay, and I want a +3 and I want a +4 in here. And it doesn't matter what order you write these in. You could write it x plus 4 and x plus 3, okay? It does not matter what order, because if you were to multiply this out, remember with multiplication, order doesn't matter, okay? So what does matter is the sign in front of the number. So they both need to be positives. Okay, and again, it does not matter which order. Now, I want to warn you guys, I tend to see this a lot in people who are just learning how to factor. And you guys will get, I hate to use the word lazy, but I guess it kind of could be lazy, is you'll just do this and you won't write the parentheses. Guess what? The parentheses mean multiplication, okay? And without them, there is no multiplication going on here, okay? So don't be lazy and not write your parentheses. You need your parentheses, but the order doesn't matter. It doesn't matter which one of these you have, just as long as you have a x plus 4 and an x plus 3 in there. This one. So we've got leading coefficient of 1. 1 times 24 is 24. Okay? This one has a lot of pairs. And eventually, by the way, you won't need to write down all the pairs. But before you send me a message saying there aren't any or it's not factorable, why don't you make sure you've written all of the pairs down first, okay? Sometimes, and by the way, I still write down all the pairs. To this day, I still write down all the pairs, okay? All right, so 1 and 24, 2, oh, hang on, don't forget the negatives. 2 and 12, that means -2, -12. 3 and 8, -3, -8. 4 and 6, negative 4, negative 6. All right. Now, if we look at their sums, the sum here is 25, negative 25, 14, negative 14, 11, negative 11, 10, negative 10. Okay, so there's only one of these that adds up to be 11. Which pair is that? Well, it's this one. Okay, so we want 3 and 8 to be in our final answer. Now, the other thing I'm going to tell you too is that, especially with factoring, we tend to use other variables besides x. So there's lots of variables. Obviously, we have, what, 26 letters in the alphabet. So any of the variables could be used. And I will say that this computer program that we're using, if you don't use the correct variable, it'll mark it wrong using the proper variable. And I tend to go back to x's too. Like even whenever it's u, I'll write x sometimes. And that's just wrong. You're supposed to use the variable that's in the problem, okay? So we want u, oops, u and u, because u times u is u squared. And then we want, because these are both positives, plus 3 and plus 8. And again, it does not matter which order you write those in. So here's our answer. So this time we're dealing with y's, so we know we want y and y. Okay, and again, leading coefficient is 1 times 60, which is 60. And so at some point, you won't be writing all the pairs, okay? You're going to go, oh, I know those two numbers right off the bat. So don't write down the pairs. If you see it quickly, or if you come across it as you're writing the pairs, don't keep writing, because I promise you there's only one pair that will add up to be this middle term, okay? So, but if you can't find it, by all means, write down all of the pairs. And I always start with 1. Otherwise, I tend to forget things, like I'll forget a number. I feel like we're getting close. There we go. We found it. Okay, so I'm going to stop there because there's a lot of factors for this one. Anyways, so we found the one that adds up to be 17, positive 17. And so we want plus 5 and plus 12. There we go. We're done. All right. Now, remember how I've been writing these negatives all along? And you guys are probably thinking, why in the world is she doing that? Well, if you'll look back at the last few examples, we've had plus plus, we've had plus plus, we've had plus plus, okay? So we won't always have plus pluses. In this case, we have minus plus. So the two terms have to multiply to be a positive, but they have to add up to be a negative. What does that mean? It means that we only want the negatives over here whenever we're writing down the pairs. We want them to multiply to be a positive, but we want them to add up to be negatives. Okay, so let's take a look at that. Leading coefficient is 1. 1 times 28 is 28. And now, again, if I write all the pairs, I've got 128, negative 1, negative 28. I really only care about the negatives, right? Because my middle term is negative. So let's not even worry about the positives on this one. Negative 2, negative 14. Nope, those add up to be negative 16. 3 doesn't go in. Negative 4, negative 7. Those do add up to be negative 11. Okay, so we found it. We found our pair here. So we're using t this time. So we want a t there and there. And then we want minus 7 and minus 4. Again, it does not matter what order you write those in. So minus 4 and minus 7 is our factors here. So t minus 7, t minus 4 is our final answer. This one, check this out. We've got a plus and a minus. Okay, don't be freaked out by this. Watch what's going to happen. I'm going to make this easy too, okay? So leading coefficient is 1. 1 times negative 5, I'm going to write off to the side, is negative 5. Okay, I want to write down all the pairs of factors of negative 5. You might be thinking, what? There's more than one? Yeah, there's actually more than one. Check this out. Negative 1 and positive 5, those multiply to be negative 5, don't they? Okay, what about +1 and -5? Haha, I tricked you kind of. But it's true because +1 times -5 is also a -5. But there's only one of these that has a sum of +4. Look, this one and this one add up to be +4, but this one and this one add up to be -4, right? Okay, so we're going to use this one. All right, so we've got z here and here, okay? And then I want to use -1 and +5. So z minus 1 and z plus 5 are my factors. By the way, can you check your work? Yeah, totally. You can distribute. Z times z is, here, I'll do that in red, z squared. Z times 5 is positive 5z. -1 times z is -1z, or you can just leave off that 1. And then -1 times +5 is negative 5. There we go. Now combine your like terms. And we should have our original problem right here. Yep. But keep in mind, whenever you check your work, that's not your answer. This isn't my answer. My answer is actually this thing right here, because I was told to factor it. Okay? Okay, how is this problem different than the last problem? Let's look. Well, this one has a plus and a minus, but they have the same numbers, right? This one has a minus and a minus. So it's actually going to be the other factors that we didn't use last time, but that's okay. We'll do this again. So 1 times -5, write that off to the side. And then we want to write all the pairs of factors. And there's only one of those that adds up to be -4, right? And it's this one this time. So we want z plus 1 and z minus 5. And you might be asking, does it really matter which one has the minus sign in front of it? Yes, it does. Go back and look at this problem. So whenever we multiply it back out, this one, because the positive was in front of the 5, we wound up having a positive middle term. But look at this one. Because the minus sign was in front of this 5, we end up having a minus sign in the middle, okay? So yes, it does totally matter which one the minus sign goes with. Okay, so it might be a good idea at this point for you to try one on your own. And then, so hit pause and try this on your own, and then come back and see if this is, if you got the same thing that I got. All right, so hit pause right here because I'm going to keep going. All right, 1 times -15 is what I'm going to write off to the side, which is -15. And the pairs of -15 that I'm looking for, so let's see here. It has to multiply to be a negative. That means only one number will be negative, okay? So I've got 1 and -15, -1, +15. 2 doesn't go in. I've got 3 and -5, -3, +5, and that's all of them, okay? There's only one pair that has a sum of -2, okay? This one has a sum of -14. This one has a sum of +14. This one has a sum of -2, and this one has a sum of +2, okay? So it's this one that we're going to use, all right? So Q goes here and here, and then I want a +3 and a -5. And again, doesn't matter which order you write that in. All right, so let's take a look at this one. Leading coefficient is 1. 1 times 15, +15, is 15. I'm going to write down all the factors of +15. So 1 and 15, -1, -15. 2 doesn't go in. 3 and 5, -3, -5. Are there any other factors? 4 doesn't go in, so it can't be. So let's look. This one has a sum of 16. This one has a sum of -16. This one has a sum of 8, and this one has a sum of -8. Wait a minute. None of them have a sum of -6. Well, this happens sometimes. What this means is that this guy is not factorable. And we call that, whenever it's not factorable, prime. So that polynomial is prime. All right, so one thing I have not mentioned to you yet, it hasn't really come up, but now it is that these polynomials need to be written in standard form. That means that you need to write it in the version of the highest exponent value of x down to the lowest, okay, down to your constant term. All right, so this one is not written in standard form. So before you factor, you need to turn it into standard form. Now, you might be wondering, why did I put a plus in front of this 2x? Well, this is a positive 2x, right? If it had been a negative, what would be in front of it? A minus sign, okay? And this is a positive x squared. This minus sign is for the 48, okay? So make sure that you carry the sign that is to the left of the term with it, all right? Now, we're going to take 1 times -48. We're going to write it off to the side. So I want the pairs of factors of -48 that add up to be 2. Okay, so we've got, let's see here, 1 and -48, -1, +48, 2 and -24, -2, +24. We've got 3 and -16. We've got -3, +16. Let's see here. Let's keep going. 4 and -12, or -4, +12. 5 doesn't go in. We've got 6 and -8, and -6 and +8. And that is every single pair of factors. Okay, there's only one pair that adds up to be 2, +2. Okay, this one has a sum of -47, +47, -22, +22, -13, +13, -8, +8, -2, +2. I don't know about you guys, but I tend to live by Murphy's Law. So mine will 9 times out of 10 be the last one that I wrote. But if I tried to start there, I'd mess it up. So this is the one we're looking for. Okay, so we would write this. We've got x here and here, and then we've got -6 and +8. And again, if you want to check your work, just multiply it out. All right, some of you are really into having notes that look like this, and you're totally welcome to have this. I am not a fan of memorization. Like, memorization had its place when we were kids and learning our multiplication tables because it definitely made us faster at math later. But now I feel like if you memorize something, it'll last for seconds. But if you understand something, it'll last forever. So it's great if you want to read through this page, but by no means do I expect you to memorize this or have this in your notes. Just read through it and see if it makes sense. If there's something about it that you're confused about, just let me know. So sometimes we have more than one variable in a polynomial, and that's okay, okay? Right now, we're only going to worry about the coefficients, what we write off to the side. So 1 times +36 is +36, okay? And we want factors of 36 that add up to be 12. Now, this one I happen to see pretty fast, right? 6 and 6. 6 times 6 is 36, and 6 plus 6 is 12, okay? So we found our pair. If it helps, write them all out, but you don't have to, okay? Now check this out. We've got an x here and an x here, right? But what do we have at the end? We've got y squared. So that means we need to have a y here and here, okay? And what numbers go in front of the y, guess what, are these, okay? And we've got +6, and +6. Okay, and a shorter way to write this problem or this answer would look like this. Okay, that's squared up there. All right. Now, if you multiply this back out, you do end up with a xy term in the middle. Remember, x times x, you get x squared. Y times y, you get y squared at the end. But look what happens whenever you multiply this times this, and then this times this. You get your xy term. All right, you may have heard me say before that I really hate using s as a variable because my s's tend to look like 5s. But they do occur every now and then, so I try to make them look more like s's and less like 5s if I can. All right, 1 times -9 is -9. I want factors of -9 that add up to be -8. So 1 and -9. Guess what? We found it right off the bat. Okay, so it multiplies to be -9, but it adds up to be -8. Okay, so we've got an r here and an r there. Because I have s's, I want an s there and an s there. And I want a positive 1 in front of that s and a -9 right there. Okay, and a shorter way to write this is, of course, r plus s. You don't need the 1, and r minus 9s. Last one. Okay, we're going to do the same thing as before. 1 times -12 gives us -12. I want factors of -12 that add up to be -9. Let's see here. I don't know that I could find any off the top of my head. Let's write them all down. So I've got +1, -12, -1, +12, 2 and -6, -2, +6, 3 and -4, -3, +4. I don't know that I see any that add up to be -9. This adds up to be -11, +11, -4, +4, -1, +1. I don't see any that add up to be -9. So on this one, I would definitely call this prime. But you know what? If I hadn't written this down over here, I wouldn't feel certain about this answer. For whatever reason, prime was always one that made me second guess myself. And so writing down the pairs of factors and then doing that math really does make me feel better about my answer. So I hope that helps you. Again, if you have any questions or need any help, let me know.